Welcome back, chemistry fans. Today we're going to do the warm-up for day 24. Let me share with you my screen so that you can get started on this, even though I am not there. All right, so on this first one, what it's asking us to accomplish is to understand what is fission. So this is two different terms that are very similar sounding. We have to understand the difference. Fusion means for them to come together. Fission is for them to break apart. So if you can just simply know that what happens during fission, atoms split apart into smaller pieces. That's good enough. What is radiation made of and how does it move? Well, it moves fast, close to the speed of light. And what is it made of? Parts of atoms. So this is what happens after fission or after fusion. When the atoms smash together, they break apart into smaller pieces that fly out very, very fast. What are the three primary forms of radiation? We have alpha, beta, and we have gamma. Alpha is a helium nucleus. It is 2 protons and 2 neutrons, but it has no electrons, so it's just a helium nucleus. Beta particle are the electrons. And gamma, well, that's just simply light energy. It's very tiny particles that we cannot see, detect at least. And so they're a part of the electromagnetic spectrum. They're over on the far right whenever we were doing some examples where we're showing you some of those examples last class. But they are the most dangerous because they are the smallest of the particles, moving the fastest and being able to penetrate just about any source of protection that you have. All right, number 4 is asking us to balance this. And now this over here is for the people who would be participating on whiteboard. You're not doing that. You're just practicing this on your own. So what we got to see is that the top numbers are equal to each other. So that means the top number on this blank is going to be 0 because 129 equals 129. Then on the bottom, however, we have 53 and 54. Well, those don't equal. So we need this 54 to be lowered by 1. So that means we need to subtract 1. That means that we have a beta particle. So you could write it as an electron. You could write it as a beta particle, whichever it is. These are the symbols. These are the numbers that are associated with those 3 forms of radiation. Alpha particle is a 4 and a 2. Beta is a 0, -1, and gamma is just so small that it doesn't have any mass and it has no protons. All right, write the balanced nuclear equation for the reaction between curium, and I believe curium is Cm246, and it is going to combine with carbon-12, which is element number 6, and it's going to produce 4 neutrons. Neutrons have a mass of 1, but they have no protons and some other element. That's the blank that we're looking for. Now, curium is element number, let me see if I can find it. Cm96, I believe is what it is. Let me make sure about that one. Yep, 96. Okay, so now we have on top, over here on the left, we have a total of 258. On the left, we have a total so far of 4, so that means I need to add to it 254. Now on the bottom, I have 102. On the bottom, I have 0. So I need to find that this is element number 102, and if I go and look on my periodic table, that's nobelium, No. No. All right, this is everything that I hope that you should be able to understand. Let me add this in for you as well, though, that on the nuclear power plant, there's an acronym that will help you memorize it. It is not me. And not me stands for nuclear power first, then thermal second, then mechanical, and then electrical. This is how electricity is made in a nuclear power plant. So if I were to add this, so if I were to look at an image of a nuclear power plant, I can progress through the images as such right here. Just give me a second. Let me find those pictures. So here we have the nuclear power plant. A nuclear reaction occurs on the left side. As it releases this controlled amount of radiation, it heats up water. That is where it turns into thermal energy. The water is so hot that it turns into steam. That steam is then moved past a turbine, which causes it to spin. That's mechanical energy. The mechanical energy of the spinning then is inside of a generator, which creates electricity. So that's how we create electricity through nuclear power plants. Okay. Last details down here, just make sure that you know some of the uses for it. The pros is that it's rather cheap. It has no greenhouse gases. It has a lot of energy that comes out. The bad thing is that it's dangerous. It takes a lot of regulations to get it safe. And we don't know what to do with all of the nuclear waste after it's done. That's the sad part of it. And then don't forget that radiation could also be used in medicine to help cure and diagnose cancers. It can help us to understand the age of certain materials. It can be used for radiation to kill germs, and it can help control pests. Okay. So that's everything that I wish to share with you today. Thank you very much. I hope that your day is going well with the sub. Take care. Bye-bye.